Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on the Cambridge IGCSE Mathematics Paper 2, which is non-calculator paper for examination from 2025 Specimen Paper. This will be part 2 of me working through this paper where I'll be covering questions 13 through 20. Let's start. Question 13. Find the number of sides of a regular polygon with interior angle 162 degrees. If the interior angle alone is 162 degrees, then the sum of interior angles is going to be 162 times the number of sides. And let's just call that n. So sum of interior angles has this 162n and has one more formula, n minus 2 times 180. And therefore, we can write this as 162n equals 180 times n minus 2. And that means 162n is 180n minus 360, expanding these brackets. And now we bring this 360 to the other side, 162 over here. So 360, because it was negative here, now it becomes positive. That's 180n minus 162n. Because that was positive here, now it becomes negative. So that means 18n is 360 and the number of sides is 20. That's our answer. Question 14. The range, mode, median, and mean of 5 positive integers are all equal to 10. Find one possible set of these 5 integers. Well, if the mode is equal to 10, it gives us the easiest clue. There have to be at least 2 values which are equal to 10 in our list. So if the mode is 10, then these 2 values of 10 must exist in this list. Now, we need to make sure that the range, median, and mean are also equal to 10. If the range is equal to 10, that means not all 5 of them can be 10, because this range is just 0. The smallest and largest are both 10. So, largest minus smallest is going to be 0. But we need the range equals 10. And we need to also keep the median and mean the same. One way to do this is to have 3 10s. This is also possible because it still keeps the mode as 10. 10 is still the highest repeated number. And now, we need to make sure that the range is 10. So we can have numbers like 3, 13, 4, 14, 5, 15, like that. But then out of these, we know that the mean is 10, so the sum must be equal to 10 times 5, because there are 5 numbers, the mean is 10, so it's 50. So that means we have 3 numbers here, and we need 2 more numbers which add up to 50 minus all these. So that's 50 minus 30, which is 20. So 2 more numbers that add up to 20. So let's just say x plus y is equal to 20. And when subtracting them, we get 10. So x minus y is equal to 10. That's because the range is 10. So now if we solve these simultaneous equations, you'll get 15 and 5 as x and y. So we can write 5, 10, 10, 10, 15. And this would be a correct answer, of course. But this is not the only way to write a correct answer. You increase this and this by 1, 6 and 16. This would not change the range, but then it would change the mean. The median is still the same since these are in ascending order, remember? So the median is the third value, which is 10. So in our example, the median is 10. And now over here, the median is still 10, but the mean has increased. The sum right now is 52. And 52 by 5 is not going to be equal to 10. It's going to be 10.4. That is our new mean. So because we just added 1 twice, so we added 2 to the total sum. So we have to subtract 2 somewhere. So if we subtract 2 over here, we have 6, 16, and 8, and then we have 2 10s once again. This is an ascending order, so this is still the median, the third value. Adding these up, we get 50, so dividing by 5, we get 10 as the mean. The range is still 16 minus 6, which is 10, and the mode is still 10, since there's still 2 10s here. So that's also a possible answer, 6, 8, 10, 10, 16. So there's not just one possible answer. There are many, but you have to make sure they meet the following requirements given in the question right there. You have to make sure that they meet the requirements that are given in the question right here. That's the answer. Question 15. Describe fully the single transformation that maps triangle T onto triangle A. Triangle T and A have different orientations. So obviously it is a rotation that transforms T onto A. If we try a few points, rotation with what specifications though? The two things we need are the center of rotation and the angle. Of course, the shape does not change anyway other than these two in a rotation. It does not change its size, does not change its shape, nothing else. Just the angle of rotation. You only need to know for 90, 180, and this 90 can be in clockwise or anti-clockwise. And in this case, it is clockwise. Clockwise 90 degrees. And we can write this rotation 90 degrees clockwise. And what about the center of rotation? This is the coordinates. We just need to fill in the x and y. So, well, if you try different rotations of triangle T, when you get to this point 4, 3, when you try different points on the grid, this 4, 3 point, you rotate triangle T 90 degrees clockwise around it, and you will indeed find yourself at triangle A. Therefore, this rotation is correct, and the center is indeed 4, 3. So that'll be our answer. Let's go to question 16. A student measures the height 8 centimeters of each of 400 plants. A. The cumulative frequency diagram shows the results. Use the diagram to find an estimate for 1. The median. Well, the median is at halfway through the cumulative frequency, or in this case, the total is 400, so the halfway point is 200. So at the 200 frequency, we can just draw a line to the graph, and we'll see that it intersects at 30 centimeters height, so that is our median. Now part 2, the interquartile range. To find the interquartile range, we need two values, the first quartile and the third quartile, and we need to subtract them to get the IQI, or interquartile range. Now, what are these third and first quartiles? The third quartile is 75% of the total frequency. And in this case, 75% of 400 is 300, which is over here. And the 75th percentile, or the third quartile, will be over here, right in the middle of these two dotted lines, making it 37 centimeters. There we go. 37 centimeters. Now, if the third quartile is 37 centimeters, then what about the first quartile? That's going to be the 25th percentile. The 25th percentile in this case is simply going to be 25% of 400, which is 100. And down here we can see that this is 17 centimeters. So the interquartile range is 37 minus 17, which is 20. 20 centimeters is our answer. Part 3, the 80th percentile. This 80th percentile is going to be 80% of 400. So 80% of 400 is 320. Looking at the height for 320th frequency, it is 39 centimeters. So you just write that down. 80th percentile is 80% of 400, by the way. That's 320. Just because it's 2 marks, you can write that down over here. 320th value, and therefore you get 39. Now part 4, number of plants with a height greater than 60 centimeters. Well, a height greater than 60 centimeters is all on the right of this line over here. So the line height is 60 centimeters intersects the graph at the middle between 360 and its next line here. So we need to find out what's the gap between one of these tiny lines here. So the gap between 5 lines is 400 minus 360, which is 40. So the gap between one line is 40 divided by 5, which is 8. So between 360 and 368, which is the next line, this 60 centimeter height frequency is there, and that's going to be 364th. So if we draw a dotted line down here to 60, now the 364th value is at the line height is 60 centimeters. So the number of plants with a height greater than 60 centimeters is going to be all the remaining plants after the 364th one. 400 minus 364, which is 36 plants. That's our answer. Part B, the heights are also shown in the frequency table. They're all given here. Complete the histogram to show this information. First, we have to find the frequency density for each of these classes. But to find the frequency density, we need the class width, otherwise CW. And by the way, frequency density in this table, I'll write as FD for short. So CW, or class width, that's 20 over here, because 20 minus 0, the ending minus starting value of the class is the class width. So 20 minus 0 is 20, 30 minus 20 is 10, 40 minus 30 is just 10 again, and 80 minus 40 is just 40. So now frequency density is going to be the frequency divided by the class width for each of the classes. So 120 divided by 20 is 6, 80 divided by 10 is 8, 124 by 10 is 12.4, 76 by 40 is 1.9. So the first bar is drawn already, which is 0 to 20, frequency density 6. It's this column right there. Now we draw for second, third, and fourth columns. Frequency density 8 from 20 to 30. So we can just draw these lines here and connect them at the top. And this top has to be at frequency density 8. Now 30 to 40, frequency density 12.4. We can see that this total distance, 5 small units, is 2 frequency density units. So 0.4 frequency density units is one of these tiny gaps. So we add 12 plus one of those tiny gaps to be 12.4. And now we just connect these lines right here. Connect the two lines there. Let me just move it up a bit to make it correct. There we go. That's our third bar. And the fourth bar is class width of 40 and frequency density 1.9. So just ever so slightly below the 2 mark. And go down like that. So that's our answer. Let's go to question 17. The diagram shows cyclic quadrilateral ABCD. BD and AC intersect at the point X, which is given here. A. Angle BAD is 74 degrees. Angle BCA is 34 degrees. Find 1. Angle BDA. This angle we need to find. Well, this is quite easy since angles subtended by the same chord are equal. In this case, a chord AB subtends angle ACB and ADB. So, angle BDA is 34 degrees, just like the angle over here. They are equal. Part 2. Angle BCD. We can see a cyclic quadrilateral ABCD. So, if one angle on this quadrilateral is given, we can find the opposite angle, in this case angle BCD, which we need, by just doing 180 minus this angle here. And therefore, it's just 180 minus 74, which is BCD, and that's 106 degrees. Part 3. Angle ABD. Well, we know that angle ADB is 34 degrees, and angle ABD is on the same triangle as these two. So we can just subtract 180 minus these two, and we'll get the third angle of the triangle. So 180 minus 74 minus 34, which is 72 degrees. That's our answer. Part B. In the diagram, triangle ADX is similar to triangle BCX. BC is 4.5 centimeters. Let's just label this. AD is 9 centimeters. Label that as well. CX is 3.3 centimeters. Work out XD over here. You might think that this is a long process because these are similar triangles. We know that this side we can find using the fact that they're similar triangles. We have side ratios, and then we need to take some sine rule, cosine rule, either one of the two, and then find this side xd. And you might be thinking, why this question is 2 marks only then? Well, that's because there's a much simpler way to do it. Since we know the side ratio, that's just BC is to AD, 4.5 is to 9, 1 is to 2 is the side ratio. Now you can find the area ratio. That's just 1 is to 2 squared, so we square both sides, 1 is to 4. Now why is this so important? That's because we're actually going to find the area of the two triangles and use this ratio. So you can find the area of this triangle here because we know two sides and the angle enclosed by the two sides, half AB sine C. This is the smaller triangle, so half AB sine C for this triangle, triangle CBX, is going to be equal to half AB sine C of triangle ADX, but multiplied by the ratio we have here, 1 is to 4. So this 1 corresponds to this triangle, 4 corresponds to this triangle. So that means triangle CBX is 1/4 of the area of ADX. Or in other words, you have to multiply 4 times this area to equate them. So we can substitute in the values. So half times 3.3 times 4.5 times sine of the angle 34 degrees is equal to half times 9 times the unknown side, let's just call it x, times the sine of 34 degrees once again. Well, since there's a sine 34 on both sides, we can simply eliminate them. We can cancel them out. And this 4 times half will become a 2. So once you multiply half times 9 is 4.5. And 4.5x equals 2 times 3.3 times 4.5. Therefore, the simplest way to find x, just divide both sides by 4.5. X is equal to 2 times 3.3, which is 6.6 centimeters. And that is the value or length of side xd, and that'll be our answer. Let's go to question 18. F of x equals 3 minus 2x. G of x equals 2x plus 3. H of x equals 2 to the power of x. A. 1. Find f of negative 3. Well, f of negative 3 is just substituting x is equal to negative 3. 3 minus 2 times minus 3. 3 plus 6, which is 9. That's our answer. Part 2. Find gf of negative 3. That's going to be g of f of negative 3. And since we know what f of negative 3 is, that's just 9, we can just substitute x equals 9 to g of x. 2 times 9 plus 3, which is 21. Part B. Find f inverse of x. Let's just write that y is equal to f of x to make things simpler. Y is equal to 3 minus 2x then. And now, to find f inverse of x, we want to make x the subject. So 2x is equal to 3 minus y. X is equal to 3 minus y by 2. Now this function we have over here, when we get x as the subject, that is our f inverse of x. So f inverse of x is just this function, right? 3 minus y by 2. Well, wait. That's not a final answer. If you write it like this, we lose at least 1 mark. Why? The function is supposed to be in terms of x, but we're writing a y variable there, which we introduced on our own. We're not supposed to write this in the final answer. We're supposed to change it back to x because this is an inverse function. So f inverse of x is 3 minus x by 2. Now we have the correct answer. Part C. Find x when g of x is equal to 7. That means g of x is equal to 7. G of 2x plus 3 is equal to 7. 2 times 2x plus 3 plus 3 is equal to 7. Now you can solve this equation normally. 4x plus 6 plus 3 is equal to 7. So that means 4x equals negative 2. X is equal to negative half. That's our answer. Now going to part D. Find x when h inverse of x equals 5. So if h inverse of x is 5, that means h of 5 is equal to x. Because if we do h of both sides, so h of h inverse of x just becomes x, and that's equal to h of 5. And that's what we have here. So h of 5 is equal to x, and that means 2 to the power of 5 is equal to x. X is equal to 32. That's our answer. This is the simplest method, although yes, you could find out h inverse of x, but then that would require knowledge of logarithms, which you do not really need for extended maths 0580 paper. Although yes, if you do know about them, feel free to give it a try. The inverse function h inverse of x will simply be log base 2 of x, and plugging in this is equal to 5, 2 to the power of both sides is this, and this will cancel out, causing x to be equal to 2 to the power of 5. That's what we got anyway. X is 32. That's correct only, but then this is just a much easier method and requires much less working. So we can use this. That's our answer. Let's go to question 19. Question 19. A. Simplify the square root of 32 plus the square root of 98. This may look impossible because, well, these two are not perfect squares. Of course, use simplification of surds. These cannot be simplified into whole numbers, but yes, they're irrational numbers as well, but you can still simplify them into one single surd. How? Square root 32 plus square root 98. That's just square root of 16 times 2 plus the square root of 49 times 2. 16 and 49 are square numbers, so they can be removed by square rooting either of these. So square root 49 is 7, and square root 16 is 4. So it can be put outside the square root. So 4 root 2 plus 7 root 2. And because these two contain the root 2, so you can bring root 2 out. Root 2 times 4 plus 7. That's just 11 times square root 2. And that is our final answer. We have simplified these surds into 1. B. Rationalize the denominator. 1 by square root 2 plus 1. First of all, how do you rationalize the denominator? You need to take the conjugate of the denominator and multiply it on both the numerator and denominator. So what is the conjugate of root 2 plus 1? We have to just flip this plus into a minus. If it was already a minus, then we just make it a plus. In this case, root 2 plus 1 conjugate is root 2 minus 1. So we can make this by multiplying both numerator and denominator by root 2 minus 1. That will not change anything because this is still 1, but it will make the denominator rational. That's what we mean by rationalizing the denominator. That just means you need to make the denominator a rational number. And we need to remove all the surds. That's the point. Now we multiply the denominators. This is a plus b times a minus b. A squared minus b squared. You see where this is going? Root 2 squared is just 2. And 1 squared is just 1. So 2 minus 1. That's a rational number, which is 1. And the numerator is just root 2 minus 1. So dividing by 1, we get the same thing. Root 2 minus 1, which is our answer. Question 20. Y is proportional to 1 by root x. When y is 8, x equals 4. Find y when x is 49. So if y is proportional to 1 by root x, that means y is equal to k divided by root x. Now how do we find this value k? We have when y equals 8, x is equal to 4. So 8 equals k by root 4, and that's k by 2. K is simply equal to, in this case, 8 times 2, which is 16. Now we know what k is, so when x is 49, we can find the y value. So y is equal to k, or in this case 16, by the square root of 49. That's 16 by 7. We can leave it like this if you want, or you can make it a decimal, but it will be recurring. So it's best to just leave it like 16 by 7, or in a mixed fraction form to 2 by 7. That's our answer.